Okay, students. So we shall continue with our vectors chapter. So in this vectors chapter, we have already completed some of the concepts and we also seen the observations of dot product. Clear? So now we shall continue with the concepts of dot product which we have already seen and we shall already completed the observations. So let us see the further concepts. So next we have two important properties of scalar product. Clear? So two important properties of scalar products are, the first one is distributive of scalar product over addition. Distributive of scalar product over addition. That means, see here, we are going to have vector A, vector B and vector C as three vectors. Here distributive of scalar product means dot product, that is vector A dot, this is scalar. Clear? See here, distributive of scalar product over addition means this is scalar. Scalar is distributive over addition of two vectors, that is vector B plus vector C. So distribution means A is going to distribute for B and C with addition, that is vector A dot vector B plus vector A dot vector C. Clear? So very simple scalar product distribution over addition. So you have to remember this. Clear? Please remember, that is the distribution of scalar over addition. That means here the scalar term dot product is going to distribute over addition of two vectors B and C, that is vector A dot vector B plus vector C is equal to vector A dot vector B plus vector A dot vector C. Very simple. So next let us see what is the next property. The next property is, let A and B be two vectors. Let A and B be two vectors and one be any scalar, one or L. They are taking here it as lambda, so this is nothing but lambda. Clear? Lambda be any scalar, then see here lambda is scalar multiplied with A dot B. That can be also written as vector A dot B and multiplied with lambda, or further it can also written as vector A dot lambda vector B. That means lambda can be multiplied to any of these two vectors. Either you can make first dot product, then you can multiply with scalar value, that is lambda, or you can multiply scalar value with B and then you can make dot product with that particular term. So it is not going to give you any problem. That means, see, let us take one example. Let lambda be equal to 2, vector A be equal to I cap plus j cap plus k cap, and vector B equal to I cap plus 2j cap plus k cap. Now 2 times of vector A dot vector B is equal to what? See here, first I can make dot product of A and B. I can make the dot product of A and B, that is I cap plus j cap plus k cap dot with I cap plus 2j cap plus k cap, and for this I can multiply with 2. Clear? That's what they are explaining here. That means first you can make the dot product of the given two vectors, then you can multiply it with scalar. Clear? Either first you can multiply, or this also can be written as, see, this term I am going to solve now. That means lambda times of b. First I will write a as it is, I cap plus j cap plus k cap dot with, see this lambda times of 2. So lambda value is 2. Therefore, lambda times of b means this 2 multiplied for b. So that will be 2i cap plus 4j cap plus 2k cap. Now you can simplify this. This is your the second property, and the first property is, that is scalar distributes over addition, and the third one is scalar can be multiplied to the dot product, that it says lambda times of vector a dot b can be written as lambda times of a dot b, also can be written as a dot lambda times of b. Okay, so here the making of this simplification we are going to study further in this particular class. So now let us write this much only. In the end of this class, or by the end of this class, you are going to learn what this thing is going to be equal to. Right, now let us write only this much, but by the end of this class you are going to learn the product of this I cap plus j cap plus k cap with 2i cap plus 4j cap plus 2k cap. In the next slide, I am going to explain the product of these two vectors, how we are going to be multiplied. Already you know, vector a dot vector b is going to be equal to magnitude of a into magnitude of b into cos theta. This thing already you have learned in the scalar product. Already you have learned in the scalar product, and you also seen the observations of this scalar product. Clear? Observations of this scalar product are already done, so no problem. Now suppose you have this type of things, how to multiply? See here, you have to find the magnitude of this, you have to find the magnitude of second vector. You will write magnitude of a here, that will be root 3. Here the magnitude of b is square root of 2 square 4, 4 square 16, 16 plus 4 20 plus 4 24. So this will be root 24 into cos theta. Here theta value is unknown, so product is incomplete. Okay, then how to find the product of this particular a dot b when the angle is not given? When the angle is not given, right? That thing we are going to learn in the next slide, but here you just be perfect with this statement, first one and the second one. First one is distributive property, and the second one is scalar multiple property. First one, that scalar distributes over addition, and in the second one scalar can be multiplied to the dot product. That is, first you can make scalar with a and you then make a dot with b, or first you can make a dot b, then you can multiply with scalar, or you can multiply scalar with b and then you can multiply it with a. In this any of the situations, your term is not going to be vary. That means all these terms are going to be give you the equal value, Okay, so let us move to the Next slide. Okay. So in this slide, let us see how to multiply how to multiply two vectors A and B without angle. As I said in the previous slide, we are going to learn to multiply the two vectors without angle, without using cos theta. Okay, so let us see this. If two vectors A and B are given in component form as a1 I cap plus a2 j cap plus a3 k cap and b1 I cap plus b2 j cap plus b3 k cap, then their scalar product is as it is given here. Okay, see this: a1 I cap plus a2 j cap plus a3 k cap dot with b1 I cap plus b2 j cap plus b3 k cap. What they are going to do? First, they are going to use property 1, that is scalar distributes over addition. Scalar distributes over addition means the first term a1 I cap, they are taking a1 I cap and they are giving the dot with b1 I cap plus b2 j cap plus b3 k cap as you do in your normal multiplication. Clear? Next, they are going to take a2 j cap plus a2 j cap. Again, they are going to make a dot product with b1 I cap plus b2 j cap plus b3 k cap. Next, they are taking a3 k cap, and by taking a3 k cap, they are going to make a dot product with b1 I cap plus b2 j cap plus b3 k cap. Clear? Okay. Here, first we shall simplify this term. Okay. a1 I cap dot with b1 I cap. That means I cap are common. a1 into b1. They are going to write a1 into b1. Next, a1 into b2, a1 into b2, I cap dot j cap. Next, a1 into b3, I cap dot k cap. Clear? Next, the same thing. A2 into b1 j cap dot a2 into a2 in a2 j cap into I cap, a2 b2 j cap, a2 b3 k cap. That thing they are going to multiply. But first, see here, we already seen I cap dot I cap is 1. I cap dot j cap is 0. I cap dot k cap is 0. So 0 into this term makes this complete term as 0. Here also make this complete term as 0. So what you are going to remain with? You are going to remain with only a1 into b1. I cap dot I cap is 1. In the same way, this j cap dot I cap gives you 0. This j cap dot j cap gives you 1. This j cap dot k cap gives you 0. That means this term and this term are going to be 0 and you are going to have a2 into b2. See this term, a2 into b2. Clear? They have already written here I cap dot k cap. Okay, here see j cap dot I cap is 0, j cap dot j cap is 1, j cap dot k cap is 0. That means this term is going to be 0, this term is going to be 0. Clear? On the same way, k cap dot I cap is 0, so this is 0. K cap dot j cap is 0, so this term becomes 0. K cap dot k cap is 1, so this term will remain as it is a3 into b3. Clear? So all terms which are previous slide, see this. In the previous slide here you can see we have taken one of the vector as I cap plus j cap plus k cap, another vector as I cap plus 2j cap plus k cap. Here this is nothing but a1 I cap plus A2 j cap plus A3 k cap. Here this is nothing but B1 I cap plus B2 j cap plus B3 k cap. Clear? If you want to make a dot product here now, if you want to make a dot product here, what you are going to do? A1 into B1 plus A2 into B2 plus A3 into B3. This gives you the dot product. A1 value is 1, A2 value is 1, A3 value is 1. So 1 here, B1 value is 1. Therefore 1 into 1 is 1, 1 into 2 is 2, 1 into 1 is 1. So here you can get answer as 4. Okay. Here also you can calculate. See, B1 is 2, B2 is 4, B3 is 2. So 2 into 1 is 2, 4 into 1 is 4, 2 into 1 is 2. Therefore, this term gives you 8 because here 2 is multiplied for this particular term. That's why it becomes 8. Here if we take directly, this becomes 4. Or in the next slide, let us take some example also. No problem. Okay. So here, see this. Oh, sorry. This we have taken C1 into C2. Sorry, this is wrong because A1, B1, we are okay. Vector A is A1 I cap, A2 J cap plus A3 K cap. Vector B is B1 I cap plus B2 J cap plus B3 K cap. So here we have vector A dot vector B equal to A1 B1 plus A2 B2 plus A3 B3. Let us choose one example. A as 2 I cap plus 3 j cap plus 4 k cap. Vector B as 3 I cap, 2 j cap, 6 k cap. Clear? So now if you want to calculate A dot B, this will become A1 into B1, that is 2 into 3 is 6 plus 3 into 2 is 6 plus 4 into 6 is 24. So this becomes 36. So A dot B, anyways this is a scalar product, the output must be the scalar. So this term is going to be the scalar value, that is 36. Clear students? So I think these particular terms are very much clear to you. Okay, because this particular product is very important for your further studies. So that's why make sure that this particular concept is very clear. Okay, let us move to the next slide. Okay students, so here we are going to study projection of a vector on a line. Okay, so first you understand this. What is projection of vector on a line? There will be a line like this. I will call it as L, and this I will take it as A. Now I want to learn projection. This projection of vector, that means I must choose one vector, call it as AB. So call it as AB. So this AB vector is going to make a projection on this line L. Take this point as C and this will become vector AC. So by doing this construction, you are going to see an angle theta here. Projection means a simple thing, that is, suppose if this is a vector AB and the shadow of this vector AB is going to fall on this line L, and that is nothing but your simplification, that it will is going to be a projection of AB on line L, projection of AB on line L. So here the projection, see, projection of AB on line L is vector AC. See this. This is vector AC. This is going to be the projection of AB on line L. That means you have to find this AC vector. Are you getting my point? Here AB and L are just the face of finding the projection, but the real thing comes with vector AC. So vector AC gives you the projection of AB on line L. So for that I will take it as vector P. So vector P is going to be equal to, see here, magnitude of vector AB into magnitude of cos theta. Clear? How this is going to be solved? See here, what is cos theta equal to? That is adjacent by hypotenuse, that is vector AC by vector AB. So now what is vector AC is equal to? Vector AB cos theta. So now projection means magnitude. So this magnitude gives us the projection of AB on line L. Clear, students? So this is what here they are explaining. Okay, this all explanation I have already explained with this diagram. Okay, if you want, let us see it again. See what they are telling. Suppose a vector AB makes an angle theta with a given directed line L. That means AB is making an angle theta with line L in the anti-clockwise direction. That what we have considered here, anti-clockwise direction. Then the projection of AB, as I said, see here, projection of AB on line L, projection of AB on line L is a vector P. That is nothing but vector AC. See here, we have taken vector AC as P, is a vector P with magnitude mod of AB cos theta. See, already we have calculated here mod of AB cos theta. That is what they are again explaining to us. Okay. So, and the directed P being the same or opposite, to that of line L. Okay, this we have not discussed. Here, this we have already discussed, and this all thing is over. Next, one more thing is direction. Okay, this direction depends on theta. See, this theta direction depends on this theta. As this theta goes on increasing from first quadrant to second quadrant, see, this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. As it go on changing from first to second, second to third, third to fourth, the direction of P is going to change. That's all they are explaining here. Is depending upon whether cos theta is positive or negative. First thing, projection of AB on line L is P, that is mod of AB mod of cos theta, and the next one is the direction of P depends on this cos theta. Okay, the vector P is called a vector P is called projection vector, that we have already know, and its magnitude mod of vector P is simply called as projection of vector AB on the directed line L. See, this already we have discussed. Okay, so these are the four examples which are given in the textbook from all four quadrants, that is, this is in first quadrant, this is in second quadrant, this is in third quadrant, and this is in fourth quadrant. Okay, so sign depends. For example, in the first quadrant cos is positive, in the second quadrant cos is negative, in the third quadrant cos is negative, in the fourth quadrant cos is positive. That means whenever theta is in second quadrant, P becomes negative. Whenever theta is in fourth quadrant, P becomes negative. Okay, whenever it is in fourth quadrant, your vector P is positive. Clear? Positive in P is positive in first and fourth quadrant. Negative in second and third quadrant. Clear? So this is what your projection, all about projection. Clear? So now let us see the further observations of this projection. I think these particular terms are very much clear. So please make a note that projection of AB on line L is, see this, mod of AB cos theta. Projection of AB on line L is mod of AB cos theta. Okay, so this thing I have explained in this particular slide, and the negative and the positive direction of P depends on the angle of cos theta. So next we shall go through the observations. In the next slide we shall go through the observations. Okay.